Hi, welcome to this channel. This is Power Learn Science and Maths TV. If you are new here, on this channel I talk about maths and science related stuff. So if this falls within your interest, I'll be glad if you subscribe to this channel. Now in this problem, we are to solve for the values of p if the quadratic equation x squared minus 3x plus 1 is equal to p into bracket x minus 3. Now to be able to solve this problem, but anyway, before I move forward, I'll be glad if you pause the video and try your hands on this. Now to solve this particular problem, we need an idea of what we call the discriminants. The discriminant. Now for every quadratic equation, there is what we call the discriminant. Now generally, the solutions for quadratic equations are of the form, that is, if you have ax squared plus bx plus c is equal to 0, the values of x can be negative b plus or minus square root of b squared minus 4ac all divided by 2a, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So if you have 2x squared minus 3x plus 4, 2 is the a and negative 3 is the b and c is the c. Now what I'm saying is that what you have in this brackets is what we call the discriminant, is what we term as the discriminant. And we use a discriminant to determine the nature of the root, because every quadratic equation has two values. All right, quadratic equations must have more than one value. There are some quadratic equations where you can have, let's say, equal values. All right, so we use the b squared minus 4ac to determine whether they have equal roots, they have different roots, they have complex roots. So to solve this problem, we are going to rely on b squared minus 4ac. Now for equal roots, always the discriminant, which is the b squared minus 4ac, is equal to 0. Is equal to 0, meaning that b squared is equal to 4ac. All right, so let's identify our b, our a, and c in this quadratic equation. Let's identify that. So to do that, what we are going to do is we have to rewrite this entire equation, all right, to look like the normal quadratic equation. And so to do that, what we are going to do is we have x squared minus 3x plus 1 minus p into brackets x minus 3, and this should be equal to 0, because for every quadratic equation the right hand side is always equal to 0. And so what we are going to do is, let's try and simplify. So we have x squared minus 3x plus 1, then expanding this will give us negative px plus 3p, and this is equal to 0. And so you have x, 3x, and you have px. So we can put these two together. And so doing that, we are going to have x squared minus x. We can factorize the x out. So that will be minus into bracket x. Then we have 3 plus p. Remember, if you expand, you end up getting negative 3x, negative px. Then finally, we have 3p plus 1. This is equal to 0. And so, what is going to happen is that we are going to compare this equation to the general equation. All right. So by comparing this to the general equation, we can say that a is equal to 1 because the coefficient of x squared is 1. And we can say that b, remember that b is the coefficient of x. And over here, the coefficient of x is negative into bracket 3 plus p. And c is whatever is left. So those without the variables, or those without x. So c is 3p plus 1. So we are going to insert these values into that because we are saying that for equal roots, remember the question says that if what you have here has equal roots, and we are saying that there is a condition for every quadratic equation to have equal root, and the condition is that the determinant, that is what is inside this, should be equal to 0. And so simplify, you get b squared is equal to 4ac. So what I'm going to do is we have a negative into bracket 3 plus p all this squared, and this should be equal to 4 into bracket a is 1 and c is 3p plus 1. And so you agree with me that negative into bracket 3 plus p all squared is the same as we are squaring 3 plus p all squared. And remember, this is equal to 4 times 3 will give us 12p plus 4. And so what we are going to do is, let's expand this. In expanding this, we are going to use the general principle a plus b all squared is equal to a squared plus b squared plus 2ab. So a is the 3 and p is the b. So this will give us 3 squared, which is 9, plus p squared, then plus 2ab. So 2 times the 3 times the p. So that will give us 6p. This should be equal to 12p plus 4. And so simplifying will give us p squared plus, now we have 6p and 12p. Anyway, let me just simplify the whole thing. So we have p squared plus 6p minus 12p plus 9 minus 4 is equal to 0. Remember, this is also quadratic, so the right hand side must be equal to 0. And so going by that, we have p squared plus, this will give us minus 6p, then plus 5 is equal to 0. This we have p into bracket p minus 1, then minus 5 into brackets p minus 1. This should be equal to 0. So we have p minus 5, p minus 1 is equal to 0. So we have p minus 5 is equal to 0, where p is equal to 5, or p minus 1 is equal to 0, where p is equal to 1. And therefore the values of p are p is equal to 5 and p is equal to 1. Thank you for watching this video. Let me know what you think of this solution. and I'll be glad to hear from you in the comment section of any new approach or any approach to this particular problem. Please subscribe if you haven't. Bye bye.